All right, class. So for Miss Shruti's class, welcome to the videos that you'll be learning with for the next few weeks. For my students, this is a continuation of what we've been doing in the past. So for our warm-up today, number one, we need to find the perimeter of triangle DEF if triangle ABC is similar to triangle DEF. AB is equal to 6.3 and DE is equal to 15.75. And the perimeter of triangle, ABC is 26.5. So what we need to do here is set up a proportion. Since we know the triangles are similar, we know that their sides are, the corresponding sides are similar too. So our proportion can be 6.3 over 15.75 equal to, now those are the two side lengths, so now we need to use the perimeters. So since 6.3 is AB, and it goes with triangle ABC, the 26.5 is going to go on top since it is the perimeter for triangle ABC. And then we'll just put P there for the perimeter for triangle DEF, what we're trying to find. So now we just cross multiply. 6.3 times P is just 6.3P equal to 26.5 times 15.75 comes out to be 417.375. Our last step to P is to divide by 6.3. Cancels it on the left, and we're left with what P is, which comes out to be, when you punch it in the calculator, 66.25. We don't have units here, so that's our answer. For number two, we are given that figure JKLM has a perimeter of 56 units. After dilation with a scale factor of 2, what will the new perimeter be for J prime, K prime, L prime, M prime? In this situation, basically what we have happening is that JK plus KL plus LM plus MJ is equal to 56. Those are all the sides of our quadrilateral that we start with, JKLM. When we do our dilation, each part is multiplied by 2. So 2 times JK, 2 times KL, 2 times LM, and 2 times MJ. That's equal to our new perimeter, what we're trying to find. We'll call P prime. Now, if you notice, everything on the left side of our last equation has a 2 in front of it, which means we can factor that 2 out. So we have 2 times all of it in parentheses, JK plus KL plus LM plus MJ, still equal to P prime. Now the next thing, if you notice, everything in parentheses is what's on the left side of our first equation, which means we can substitute 56 in for what's in the parentheses. So all we had to do is multiply our 56 times 2. It's good to know why we can do that. So 2 times 56 comes out to be 112. And once again, here we have no units, so we can leave it as just 112. So today's lesson, we're going to start looking at geometric means and Pythagorean triples for our vocab. The geometric mean, just like we had before, the mean, when you think of that math term, you think of arithmetic means, which means we're looking at the average, right? Geometric means are different. So now we have to actually have a proportion set up where the numerator in one is equal to the denominator in the other, and then when we cross multiply, they'll just end up multiplying to get x squared equal to the other two numbers multiplied together. When we square root both sides, x is our geometric mean, and a and b are just two positive numbers. If they weren't positive, we would end up with a negative inside, and that would be a problem. So let's look at how we do this. The geometric mean between 2 and 50. So our equation we just looked at, x is our geometric mean, is equal to the square root of a times b. In our case here, a is 2 and b is 50. So we just plug those in. 2 times 50. And of course, 2 times 50 is 100. And the square root of 100, or the number that you multiply by itself to get 100, is 10. And that's it. The next thing is looking at right triangles. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So let's look at an example with this. Here we have a right triangle with an altitude split into two triangles now. The one is red, the other one is blue. And we need to write a similarity statement. So we're just going to write out the names of our triangles. So you can kind of see the picture and tell just by looking at it what the angles are the same-ish, like G looks like it's the smallest angle of the overall triangle, which means it's going to be the smallest angle for the red triangle as well. So if you want to do it that way, you can do it that way as well too. So what I'm going to do though is I'm going to write out the first one, the whole big huge triangle, the whole thing, GEF. It's going to be similar to another triangle. I'll start with the red one because the red one has G in it, and G isn't being split in half. It's just the same angle for both. So that means G needs to go first for our second angle. Now, E is our other angle we used. That's the second angle for the first triangle, and it's the other one that's not a right angle, which means that whatever one is not the right angle for our other triangle, the red triangle, that's our next name, or next angle. And in this case, G to F, F is our angle that is not right for the red triangle only, so that's what goes next. And H is our last angle, and it is our right angle, which is good because that's where our right angle was for our first triangle. So now we do the same process for our last triangle, the blue one. In this case, we look for the smallest angle to start, and that's F. E is our angle that is not right here, that's left, and the right angle in this one is H as well. So there's our similarity statement. That's all we had to do for that problem. Now the next thing we're going to do is take the two things we just did, the geometric mean and the angles, or the similarity between triangles for an altitude, and we're going to apply them together. So geometric mean theorem says the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of the altitude is the geometric mean between the lengths of these two segments. And there's also the leg version of it, that the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of the leg of this leg of this triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So in this case, A and Y are both colored green on purpose because that Y is the segment of the hypotenuse adjacent to leg A. Same for X with leg B. And then C is the entire length of our hypotenuse. So let's look at an example with this. Here we have triangle JKL. We want to find E, C, and D. They're all different parts of the overall triangle. E is the altitude, D and C are the legs. So what we're going to do first is look at E, since it doesn't require us to do any additional math. We just have to do a geometric mean. So E is an altitude, which means that the parts that it splits the hypotenuse into go into our square root. So 6 times 24. And 6 times 24 is 144. And the square root of 144 is 12. Now C and D are a little bit different. We have to look for those parts of the hypotenuse that are adjacent to that leg. So for C, that's going to be the 24. We also, though, need to know the total length of the hypotenuse. This whole length here, and that's 30. 6 plus 24. So 24 times 30 is inside our square root, and 24 times 30 comes out to be 720. And the square root of 720 is not nearly as pretty as our last one. Comes out to be 26.833. That is not 833 repeating, I rounded. D, same idea, but the other leg and the other adjacent piece of the hypotenuse. So the square root of 6 times 30 now, instead of 24. So 6 times 30 comes out to be 180. And the square root of 180 comes out to be 13.416. Our next problem, Miss A, I don't know how to pronounce her name, is constructing a kite for her son. She has to arrange 2 support rods so that they are perpendicular. The shorter support is 27 inches long. If she has to place the short support 7.25 inches from one end of the long support in order to form 2 right triangles with the kite fabric, what is the length of the long support? So what we need to do here is actually go in and figure out some things about our picture before we do any actual calculations about our answer. So first off, we need our altitude, and we need the other length, which is the hypotenuse for both of the right triangles. And we don't know part of it, we do know the other part. We know the 7.25 inches. We don't know this red X portion. And overall, we're looking for the entire hypotenuse, which is that 7.25, and X. We'll call this portion L for the long support. So first off, we can easily find our A, because we know the entire length of that support is 27, and it's half of that. So 27 divided by 2 is 13.5. So now that we know our altitude, and we know half or one part of our overall support, or the hypotenuse, we can set up our geometric mean. So A is equal to the square root of the 7.25 times X. So now we can plug things in. We know our A is 13.5, and we can combine the 7.25 and X to be 7.25X. To solve for X here, we're going to square both sides. So we square 13.5 and we square the square root, which cancels it out. And we're left with 13.5 squared is 182.25 equal to 7.25x. When we divide by 7.25, cancels on the right, and we're left with x equal to 25.138 when you round. So now we can plug that in. We know that L is equal to 7.25 plus what we just got, our x. When we plug that in, L is equal to 7.25 plus 25.138. So our L comes out to be equal to 32.388. So with that said, here is our exit ticket for today. And for Ms. Shruti's class, I'm going to make another video that is actually going to combine this lesson with the next lesson so you guys can get caught up.